All right, this lesson we're going to talk about parallel and perpendicular lines from graphs. So the first thing we need to be able to do is actually graph a line, which we did in the last lesson. And we talked about how to graph this line. We first begin with the b. We start with the -5. So on this graph, we would start with -5, which would be here. This slope tells us that we would go 3 up and 1 to the right. And we would continue doing this for as many points as we felt like we needed to for this problem. So this would be a sufficient graph. And if we start here and we go up 3 and 1 over, we go up 3 and 1 over, you would see that that is actually the line, the graph for this particular equation. We're going to do the same thing for this equation. So again, we start at +2. So over here is +2. And then we're going to go up 3 and right 1, up 3 and right 1. And you'll get this. Now it's pretty clear to see that these look parallel, but we need to prove it. And so what I want you to understand is if we have parallel lines, which these are, their slopes, which in this problem, they're both 3. Slopes are the same when lines are parallel. So that's something important that we need to know for what's coming up on the assessments in the quiz. That's one of the properties we have. So the property, again, is slopes are the same. If the slope is 3, the other slope will be 3. If the slope is -10, the other slope will be -10. All right, when it comes to a problem like this, these look perpendicular, but we need some proof. And so we're going to use this graph to develop our conclusion. And so what we find out is if I were to graph this line A here, right, we start with the very left point. So to determine the slope, a slope from a graph, we're going to start at the left point of the line. So in this problem, this is the left point of this line. This is going to be the right point. Now, what we have to then do is determine, okay, from that point, do we go up or down? Because that's going to determine if the top number in our slope is positive or negative. And in this case, we actually go up 2. So in this case, we go up 2. And again, m refers to the slope. Then we have to determine how many to the right do we need to go. And in this case, we go 1 to the right. And so our slope will be a +2 slope, or a +2/1 slope. Now, if we do the same thing for the second line, we're going to start here. Now, this is a coincidence that it's the same starting point. Most times we actually don't start that way. And we're going to end up going this way. So again, we start at the very left, which is here. We're going to go down next. So we go down 2. So 2D refers to 2 down, and then we're going to go 4 to the right. And this is going to end up giving us a simplified slope of -1/2. All right? Now, if we look at this, these are actually perpendicular lines. And what happens is this. There's a concept called opposite, which we saw in the previous lesson when it came to slope and point slope form. So opposite means we're going to change the sign. So if you take our original slope of 2/1 and change the sign, that would make it a negative. So this would convert to a -2, but what we do to get this is to flip the fraction, and that's called the reciprocal. So for perpendicular lines, we're going to call them opposite reciprocals. Again, opposite means we change the sign, and reciprocal refers to flipping a fraction. So opposite is changing signs, reciprocal is flip the fraction. All right, so for some practice here, for perpendicular, parallel slopes are pretty easy to understand. For perpendicular, it's a little bit trickier, so I want to go through some examples. The first is this. This is a slope of 3, but it's technically 3/1. So if we were to flip this, this would become 1/3, and we change the sign to make it negative. So the answer would be -1/3. For a -5, it's technically -5/1. Flip the fraction, change the sign, would give us 1/5. 4/5, we flip the fraction, that would make it 5/4, and then change the sign, would make it -5/4. And the last one is a -1/4. If we flip that and keep it, it would be 4. Or you could write it as 4/1. Either of those is okay. All right, so hopefully now you understand how to determine perpendicular slopes. That's going to be something not specifically asked, but this is more of a skill practice that you're going to be able to do for other problems in the future. All right, so here's an example where we have problems. I give you an equation, and I want an equation that is parallel or perpendicular. Now, we're going to get into more specifics in the future, but for right now, we're just going to use mainly 0 as our y-intercept. The one thing is a parallel line is going to have the same slope, but it also needs to have a different y-intercept. So that's something that we can add to that definition, is not only are they the same slope and they never touch, but they are gonna have to have a different y-intercept. So in this problem, 2/7 is our slope. So if I want a parallel line, it also needs to have a slope of 2/7. If nothing is listed here, that means the y-intercept is actually 0. And for this example, I'm gonna keep it here. The answer could be anything, 2/7 x, any number except the number +1. Okay? I'm gonna do another parallel example here. So in this case, the slope is -1/2. So our parallel slope needs to have a slope of -1/2. Again, I'm gonna keep it at 0. Your answer could have anything except a -6. All right, the next example, if a parallel slope for this, it needs to be 4. Now I'm gonna use 0 again. It can be anything except -8. Now the last example has 0 as a y-intercept. So the parallel slope is -6. So I'm gonna use -6, and I decided to use the number +1. Again, you can use any number except 0. All right, so hopefully you understand now how to do a parallel slope and how to determine that. What we're gonna eventually do later is take these equations that are parallel to, like we're gonna need a line and equation parallel to this that goes through a point, and we'll graph that, and that will come up in a future lesson. All right, now for perpendicular, what we need to do is flip the fraction. So this would make it 7/2, and then we change the sign to make it -7/2. And just like I did for parallel, I'm gonna use 0 as the y-intercept. All right, over here we have -1/2. So this would flip and then change the sign to become 2x. For over here, this would be 4. Technically it's 4/1. So if we flip the fraction and change the sign, we would get a -1/4 for a slope. And then over here, this would be -6/1, which would be a +1/6x. Now in this case, the perpendicular lines can have the same y-intercept. It's parallel that cannot. Typically, this will not be a problem in the questions that we have and on the assessments we have, but just to point that out to you guys.